If you're thinking about using a heap, chances are you've come across a hard leet code problem. A heap is extremely efficient to use when you're trying to keep track of the minimum or maximum values from a blob of data that is continuously changing. Under the hood, a heap is a binary tree. For a max heap, the root of the binary tree is going to be the largest value in the heap. And for a min heap, you guessed it, the root is going to be the smallest value in the heap. You don't really need to remember this bit I'm about to tell you for interviews, but it helps you understand the time complexity of operations you can do on a heap if you understand this. A heap is a binary tree where every node in the tree is greater than or smaller than, if it's a min heap, all of its children nodes. And no matter what you insert into the heap will automatically adjust this structure so that it always presents the largest or the smallest value at its root. For example, if you add a new value to a max heap, it's going to be added to the bottom of the tree as a leaf node, and then it's going to get bubbled up until it finds its place in the hierarchy of values. So, for a heap that has n values, the time complexity of inserting something into the heap is going to be log of n, which is an approximation for the height of the binary tree. Here's a use case. Let's say you want to find the minimum value from a stream of data. You could store all the values in an array and continuously keep sorting it every time you get a new value, but the time complexity of sorting is n times log of n. Or you could keep inserting these values as they come into your heap, where the time complexity of insertion is only log of n. And you always have an O of one way to find the smallest value in the heap because it's always going to be at the root.